Okay. All right, assuming everybody is still here and still listening, I'll just go ahead and show off what we've done. Kind of to give a history, what we've, let me show the DSC project that everybody is most familiar with, and I'll show the old stuff. Right here is your build XML, which was the ANT build, and as you can see, there are, task definitions, and you call targets, and you can call targets from targets, which you figure depends here. And then when you run it on the command line, it ends up looking like. Clear that before I send it off to the real screen. Ends up looking like ANT. And then whatever target you're doing, like deploy or anything like that. And that's pretty good. The problem that you've got with this point is if you're going to include external jars, or if you're going to include anything else, all of that has to be within the class path. And if it's not within the class path, then you have to define where the class path is for ANT. And since all of those things have to be there in order for this to work, you then have to check them all into your version control. So you've got that nasty situation where you're violating number 2. All of these are derived artifacts. They shouldn't be there, and yet they are. And really, it's not anyone's fault. There's no way to keep these out of version control just because you need these jars. They've got to be there. They've got to be in a position where you can compile them, especially if you've got what we're doing in continuous integration environments where the builds are automatic. I mean, certainly you don't want to have to, find every single one of these on every single server that you're going to attach yourself to. So, of course, you're going to put them in version control. And then now, the slightly dirty feeling that you've got is the knowledge that you have violated the second part of version control. So, what Maven offers is this pom.xml. And like I said, with the repository systems that they put in place, it is an easy thing to now get access to your third-party compiled artifacts and to organize them in one place. And even better, because it contains its own repository of these dependencies, which is of a decentralized nature, it will be able to store all of these things that it grabs locally, where it will be able to have access to them at any point. And because of the way Eclipse implements this all, you can have a searchable interface. So if you're looking for your log4j things, it will go out and it'll search the repositories that it knows about, which in Eclipse case is the Maven Central repository, and any others that you add, which don't really have to show, but just know that they're there. And there they are. And now adding a jar into your project is just as simple as double-clicking. Yay! Also, you've got access to all sorts of properties that can be defined within this first page here. Before, with ANT, you either had to define your properties in a, or any variables that you wanted to use, you had to define them in a build, an external properties file, or in a properties element of the build itself. Not anymore. Now you can just create them, names, values, the whole kit and caboodle. Also, you've got built-in versioning. You've got different ways of packaging all of these projects up, and inheritance, which we'll again show in a minute. Now, this Maven is smart enough to figure out how not only what the PDF box is a great one. We searched for a PDF box and we added it as a dependency. But Maven is smart enough to figure out that PDF box also depends on FontBox, JeffBox, and the Commons-login. But it also is smart enough to realize that Commons Discovery also depends on Commons.logging. And what it does is it puts it all here in a nice, neat little list for you so that it doesn't bring in more than one of each, and it puts them all in correct order. And when it builds, it goes out and fetches every single one of these. It also, in this, there is no inheritance in this one, but I want to show you the effective POM. It's a nice window to see what is actually getting applied to here. What the important thing to realize when you're dealing with any POM yourself is that your POM is not an island unto itself. It always inherits from what's called the super POM, which is Maven's own pom.xml file in which all POMs derive. And so there's a lot of stuff that's in here that you didn't configure simply due to the fact that you're getting, nobody this is right here. There's in order to make sure we got the correct clean plugins coming into our build. That just is coming in from the pom.xml. You can see that each POM is able to inherit from a parent POM. That everything comes from the super. And then you've got access to what you're actually dealing with. So you've got direct XML access to it. These dependencies you can write in yourself, but don't, because this dependency window is a ton easier to use. You need to make any changes there. Just go ahead and click on that, and you get a nice little dialog box. And believe me, that's a ton easier than accidentally making a mistake in XML, because this part of it is really sensitive and it does get mad really easy. Then you've got your resources and your plugins. And remember when I said everything was a plugin? Well, here is a great example. The way that dependencies are managed within Maven is with the Maven dependency plugin. And because it is a plugin, we are able to actually get access to it, bind an additional goal to the validate phase, and the goal that's defined as the copy dependency. And that's how we're handling the build, the deployment on the servers. So we're able to copy the dependencies out of the Maven repo and install them directly into the library directory. So, okay, we need the lib directory for the Ant build to work in order to deploy this whole thing, but we now no longer have to store them in version control because we've got them in the a repository, and we're able to so we're able to actually take this out, put it into the lib folder, and now we're here. We've got a clean version control and a clean deployment, and all because we were able to directly control how Maven handles its dependencies. So I guess I'll stop there for a minute and see what questions are going on. Yeah. Oh, yeah, yeah. Just to kind of show it off, we have installed a twin internal Maven repository, and some of the stuff that everybody is using on a constant basis we put in there, which are mostly the lifecycle client jars that you pretty much have to install in every one of these projects. If you want to, you're able to just add your repository links into here on the repository part of the POM. This is a great thing to copy at some point, but you can kind of look into that. I don't want to get into a ton of the particulars on how to do this. I just kind of want to show a real high-level thing, because this is all very well documented. Really quick, I want to show off the ecomp HTML project. So I can close this. There we go. Now, the ecomp HTML project demonstrates another thing that we can do with the with Maven. A lot of the time, you run into a situation, especially in the large project sizes that we're doing, is that you've got projects that depend on other projects, but don't really go together in its own project. To give a good example, you've got our client web project and our REST servlet project. Now, these two things are functionally separate. The REST servlet is in charge of the REST services that we're providing to the web client, which are tied very closely to what we're doing here in client web, but aren't actually technically part of it. And the client web here, which is just all of our HTML and JavaScript files that we're maintaining. But because they're so functionally close together, and especially since if you're doing any debugging locally, you need to have this servlet running and local in the background, we are able to put them together into one build environment. And all of that is created with this parent POM. What we just defined under our POM is modules that will inherit from our ecomp HTML. We can define properties that will be built, that will go throughout. We've got a client web module, a REST service module. We've got even a, this is kind of my favorite part of this whole thing. It's a project that sole existence is to build the modules that are within this project, which is kind of fun. And we're able to do that with this and with the ear. So what you've got is a project with a single file, which is just a POM, and the POM's entire job is to correctly bring together all of the pieces necessary to create this HTML ear that brings in the Flex project itself. And so, and again, when you're looking at inheritance, everything inherits from the parent, and then the parent itself inherits from the super POM. So you've got a clearly established hierarchy. You can also anything that gets placed up here trickles down to the bottom, but you can also configure everything locally as well. I mean, everything is as not fine-grained or as fine-grained as you want it. To step out of the high level and show you a practical matter, what we've got in this ecom data, we were able to pull all of the relevant files that are our data model files and all of the services that interact with them into its own project. And because it's in its own project, it creates its own artifacts, creates a jar file that, if you're going to want to use it, you're going to need to bring it in. Well, now that creates a situation where you've got a jar file here that you need here. And in Eclipse, that's as easy as, establishing a relationship between two projects within the workspace. But, then now you're really tied to Eclipse. Not that you could use anything else, but now you're tied to a specific IDE implementation in order to build something correctly. Well, Maven, the entire idea behind it is portability. So with this, we're now able to bridge the gap so that even all of these things can be done on the command line. And so as you can see here, we're bringing in the ecomp data folder project and the comments. Now, because this is the Eclipse version of Maven, it knows that these are project folders, and so it does it like that. But essentially what's happening in this situation is it is going out to the local repository and looking for a project called, or an artifact called ecomp data. And it'll yank it out of the project, and it will then it will install it here. So now you don't have to worry about the dependency. The only issue at this point, of course, is that it has the latest version has to be in the repository for this project to know about it, which means if there are any changes to this project, you've got to do another Maven install.